All right, so today's skill is going to have us take a look at how to find the limit of an expression where we'll need to use either factoring or rationalizing, okay? So let's follow along with the directions here, which are pretty key, which asks us to first evaluate the limit by expanding the denominator, right? So we're given a hint here about where to start, right? Now, the reason why we would want to expand the denominator is perhaps because at some point, if we were to just use direct substitution, we might arrive at indeterminate, okay, or we might end up with a 0 in the denominator, which does not allow us to find a limit. So we want to go ahead and try something else. So we're going to start by expanding, right? So what we have here is the limit as t goes to 0 of negative t all over negative 3t minus 1 squared minus 1. We'll begin by expanding, right? So we want to expand the binomial, apply the power of 2. So if we go off to the side here, do a little bit of side work, we'll end up with negative 3t times negative 3t, which is a positive 9t squared. Negative 3t times negative 1 will be a positive 3t. Negative 1 times negative 3t will be a positive 3t. And then finally, negative times negative will be a positive 1. Okay, so the expansion gives us this, all right? But we can combine some like terms because we have 3t plus 3t. So ultimately, this actually cleans up to be 9t squared plus 6t plus 1. Okay, so we're going to go back to the limit as t approaches 0, negative t all over 9t squared plus 6t plus 1 and then minus 1. Okay, so now we can go ahead and deal with this denominator, right? Notice how our parentheses at the moment are not really doing anything. There's nothing we need to distribute into those parentheses. So we can continue, drop the parentheses, and then you'll see that there is something that we can clean up. So we have negative t all over 9t squared plus 6t plus 1 minus 1. Okay, so then if you notice 1 minus 1, these add up to be 0. So we actually end up with the limit as t approaches 0 of negative t all over 9t squared plus 6t. Right? And you might be looking at this and thinking like, okay, if I apply 0, I substitute 0 into t, I'm still going to get indeterminate in the denominator, or 0 in the denominator, or 0 in the numerator, I get indeterminate. But we haven't applied either any factoring or rationalizing. So I think in this case, we could use the factoring strategy because if I look at my denominator, I think I see a greatest common factor down there, okay? Or at the very least, I can factor something out of those two terms, the 9t squared and the 6t, and perhaps we'll have something that we can perhaps divide out. So as t approaches 0, negative t all over, I'm just going to factor out a t. Okay, I'm going to factor out a t. That leaves me with 9t plus 6. Okay, by factoring out t, now I see that I have t over t, and t over t reduces down to 1. So what we end up with is a limit as t approaches 0 of negative 1 all over 9t plus 6. Okay, and now if I were to do direct substitution, I see that I would actually end up with some value in my denominator, right? It wouldn't be 0, and this would actually allow us to reach that limit. So we end up with the limit as t approaches 0, negative 1 all over 9 times 0 plus 6. So then this tells us that the limit as t approaches 0 is going to be negative 1 over 6.